All right, so if we want to determine whether the functions are even, odd, or neither, remember we need to just substitute in negative x. If we get out the same thing, it's even. If we get out negative f at x, it's odd. Okay, so when we substitute in negative x into the first function, we're going to have absolute value of negative x minus negative x. And this is equal to the absolute value of x plus x, which is neither. So neither even nor odd. So for b, when we substitute in negative x, we're going to have the absolute value of negative x minus 3, which is the absolute value of x minus 3. So this is equal to f at x. So this is even. For c, we're going to have absolute value of negative x minus 3, and we can factor out a negative negative 1, which is equal to the absolute value of x plus 3. So again, this is neither f at x or negative f at x. And for d, negative x, so we're going to have 3 times negative x times absolute value of negative x plus 1 over negative x. So this is going to be negative 3x times the absolute value of x minus 1 over x. And here we can factor out a negative. That's going to be 3x, absolute value of x plus 1 over x. And this is equal to negative f at x. So this is odd. So for number 10, we've got f at x here. On a new diagram, sketch the graph of 6 over f at x. Indicate any asymptotes. Okay. So the first thing is that the vertical asymptotes become roots. So at x equals 2, we're going to have a root, and any roots become vertical asymptotes. So we've got at x equals 3, we're going to have a root here. An asymptote. That's a root, so we're going to have an asymptote. And at negative 2, we're going to have an asymptote. Okay, the next thing, the horizontal asymptote at y equals 2 becomes the horizontal asymptote at y equals 1 over 2. However, we are multiplying all the y's by 6, okay? So 6 times 1 over 2 is going to be 3, so we have a horizontal asymptote at y equals 3. So if we have any maxes or mins, they're going to become the opposite at the same x, but 1 over the y. So we have a max at about 4, 3. So we're going to have a min at 4, 1 over 3. But of course, we are multiplying that by 6. So that's going to be at 1/3 times 6, which is 2. So min at 4, 2, and any y-intercept is going to become the y-intercept, but at 0, negative 1 over 3, and we also have to multiply that by 6, so that's going to be at negative 2. Okay. Another thing is here we have negative function. So it's going to be, the reciprocal is going to be negative as well there. And we have positive function here above the x-axis, so it's going to be positive in our reciprocal function as well. So if this red bit is positive, we're going to be positive as well. And we can approach, as we're going towards x is negative infinity, it's going to approach the horizontal asymptote. And it will approach the vertical asymptote. All right, same thing on this side. After 3, it's positive, and we're going to have that min at 4 too. So remember, and it also can cross the horizontal asymptote. So we're going to touch that as a min, and we're going to bounce back up towards the horizontal asymptote. As x approaches infinity, it needs to approach that horizontal asymptote. And lastly, in between -2 and 3, it's negative. All right, so on the reciprocal function, it needs to remain negative. So we're going to go something like this. And it needs to approach the vertical asymptotes on each side. All right, number 11, f of x equals k over x minus k. X can't be k, and k is greater than 0. On the diagram below, sketch the graph of f. Label clearly any points of intersection with the axes and any asymptotes. Okay, so definitely at k we have an asymptote, because to find vertical asymptotes, we set the denominator equal to 0. The horizontal asymptote is going to be, k is a number, so we've got a degree smaller up top than below. So that means vertical asymptotes at y equals 0. And then we have that k is greater than 0. So that's going to be like this on one side and like this on the other side. You can substitute in x equals 0 and you'll get k over negative k, which is -1. So that's the y-intercept. And, you can kind of, if you don't feel confident, you could pick a value of k like this and see, substitute in something after k, after 2, and you'll get, a positive number, so above the x-axis, so it's going to be up here, okay? All right, B, they want you to sketch the reciprocal function. So, yes, we have to go through the same thing as the previous question. So we're going to have any vertical asymptotes become the roots. So we're going to have a root at k. And any roots, which we don't have any, would become vertical asymptotes. So we don't have that. However, we've got this horizontal asymptote at y equals 0, and it's going to become a horizontal asymptote at y equals 1 over 0, which is undefined. So basically, we don't have a horizontal asymptote. Now, if we have any maxes or mins, they will become the opposite, and the x's will stay the same, but the y's will be 1 over that. And any y-intercept, so 0, -1, is going to become the y-intercept at 0, 1 over -1, which is still there. Okay? And we have, before k, x is negative. After k, x is positive. So we need to be negative up until k and positive after k. For 12, each of the diagrams below shows a graph of the function f. Sketch on the given axes the graph of the absolute value. Okay, so first of all, let's deal with the negative x. So that's going to flip everything over the y-axis. So that's that, as best as I can do. And then we have the absolute value of that. So when it's the absolute value of the whole thing, everything flips above the x-axis. So that's going to be the graph in red of the absolute value of f of -x. Now, for 1 over f of x, we need the reciprocal. So any vertical asymptotes, which are none, become roots, and the roots become vertical asymptotes. So we're going to have an asymptote here, an asymptote here, and another asymptote here, whatever those may be. There's no horizontal asymptotes. There's a max here, which is going to become a min at same x 1 over that y. So let's just do like here, and that's a min. And then here is a min, and that's going to become a max at same x 1 over that y. So we're going to have like here. So yeah, this is going to be a max, and this is going to be a min. Any y-intercepts become y-intercepts at 1 over that. So maybe here. Okay. And then we have it's positive here. So it needs to stay above the x-axis there. So, and approaching the vertical asymptotes. So like that. It's negative in between here, so it needs to stay below the x-axis there. Maybe that should be up a bit more. This one, because that needs to be a max. So maybe like here, and approaching the the vertical asymptotes. And again, this needs to stay positive after that. So like this. Okay, 13. So we have to, this is from -2 to 8, and we want the reciprocal function. So we've got roots that become asymptotes. And 2 asymptote. And 5 asymptote. If you're graphing this on the exam, make sure and label. All right, there are no, vertical asymptotes on the f at x, so we don't have any roots, looks like. Now, there's no horizontal asymptotes, so we don't have any horizontal asymptotes on 1 over f at x. We do have some, so here is a min. We're going to have a max at 0, 1 over -2. So this is going to be a max. And we have a max at 3, 1. So we're going to have a max at, a min at 3, 1 over 1. So min. And then we have a y-intercept. Yeah, that's the 0, -2. So it's going to be 0, -1 over 2. And we just have to now pay attention. So it's positive here. So it needs to stay positive like that. It's negative between here and here. So it needs to stay negative, and that's a max. So approaching the vertical asymptotes. Then it's positive between here and here. So it needs to stay positive like this. And then we have negative after that. So it needs to stay negative and like that maybe. Okay. All right, 14, the diagram shows the graph of f at x. The equation f at x equals k has exactly one solution. Write down possible values of k. So if we want, basically we want a horizontal line that goes through our graph one time. So this all is good. It will go through once. So we have anything, so k can be greater than 1. So if f at x was 1.5, it'd be fine. Then we have basically everything until here would have one solution. At -2, it has 2 solutions, and then here it has 3, and it will keep on having 3. So as long as k is in between, so it's greater than -2, but less than 1, it will have one solution. So now in the same diagram, we want to graph the reciprocal function. So any vertical asymptotes become roots. So we're going to have a root here and a root here. And any x-intercepts become roots. So we're going to have any x-intercepts become asymptotes, sorry. All right, so there's that. Any horizontal asymptotes is going to be 1 over that. So it actually stays at y equals 1. And we have any maxes or mins. So we have a max at 0, -2. It's going to become a min at 0, 1 over -2. So this is your min. And then we don't have any other maxes. We have the y-intercept, which is also that, min. And then we have it's positive here. And so it needs to stay positive. And here it's negative. So it needs to stay negative. And here it's negative up until 2. And then after that, it's positive. So as long as it needs to approach the asymptote as it goes out and be positive. So it's something like this there for that. And then it goes negative. So it needs to go down here. This is becoming a min. And it's still negative here. So now we have taken care of this part. And it needs to be negative there as well. So, and approach the vertical asymptote. So something like that. And let me erase this bit. Okay. And then after that, it's positive. So something like this. So for C, write down the coordinates of the local max, the local min, the x-intercepts, and the y-intercept. So there is no minimum on the graph of f at x, but on the graph of 1 over f at x, since it's got to be negative here, this is going to be the max because it's the x-intercept and it's got to stay negative or below the x-axis. So that's going to be the max at 1, 0. The local min we already have at 0, -1/2. The x-intercepts are at -1, 0 and 1, 0. And the y-intercept is 0, -1/2. Okay, 15. The diagram shows f at x, horizontal asymptotes there and there. On the same diagram, sketch the graph of 8 over f at x. Okay, so we don't have any vertical asymptotes, so we can't change those to roots. We do have roots at 2, so we're going to have a vertical asymptote here. Okay. We have horizontal asymptotes, which are going to become horizontal asymptotes at 1 over 2 and 1 over -4, which is difficult to draw. Oh, wait. Because we're multiplying by 8. Okay, so that's 1/2 times 8, which is 4. So we're going to have an asymptote here. So it's 1 over 2 times 8. And this is 1 over -4 times 8. So at -2. All right. So now we have no maxes, no mins. We've got the y-intercept at 0, -2. So that's going to become 0, negative 1 over 2, but we have to multiply that by 8, so it's going to be negative 4, like that. And we just have to make sure we remain negative up until 2 and positive after 2. So we have to approach that and that. And now we're positive after 2, and we have to approach the vertical asymptote and the horizontal asymptote as we go out. So nothing's going on in between the horizontal asymptotes. All right, so B, write the domain and range. So the domain of f at x is all real numbers, and the range is in between negative 4, not equal, and 2, also not equal. And for double I, we've got the domain is all real numbers, but not the vertical asymptote 2. And we have the range, which is y is less than negative 2, or y is greater than 4.